Hello guys, so we are going to continue the discussion with respect to Python, and in this particular video we are going to discuss about Python memory management. I've seen many people who are learning Python, they usually skip this topic or they do not have a complete idea like how the memory management happens when you are implementing or when you are developing application with the help of Python programming language. So in this video, I will be covering all these things. Okay. So let us go ahead and start this particular topic. So initially here you can see I've written some description. So memory management in Python involves a combination of automatic garbage collection, okay, reference counting and various internal optimization to efficiently manage memory allocation and deallocation. Understanding this mechanism can help developer write more efficient and robust applications. So here you will be seeing some keywords like automatic garbage collection. So the entire memory management with the help of Python happens automatically with the help of garbage collection. Along with this, we'll also be seeing something called as reference counting. Okay. And there are some more optimization techniques which will actually help you to manage the memory efficiently. Okay. So in this video, we will cover all these things, memory allocation and deallocation, reference counting, garbage collection, the GC module, and memory management best practices. So let us go ahead one by one. Okay. So first of all, we will go ahead and talk about something called as reference counting. Now, what exactly happens in the reference counting? Okay. So reference counting, if I just probably define this in a very simple manner. So here is my definition. So I'll just give you this particular definition. So reference counting is nothing but, here you can see it is a primary method Python uses to manage memory. Each object in Python maintains a count of references pointing to it. When the references count drops to 0, the memory occupied by the object is deallocated. Okay. So let's say I'm just going to go ahead and import one sys. This sys is nothing but system configuration. It is related to system configuration. So we are going to use this. Let's go ahead and initialize one variable called as A, which will be a list. And now if I go ahead and print sys dot get reference ref count of get reference count of A. So if I go ahead and print this, so here you can see that it is showing the output as 2. Now let me talk about why this output is coming as 2. So here you'll be able to see this output 2 is because of one reference is probably coming from A variable and one from get ref count function. Okay. So since we are using this particular function, this is also referring to A, and A is assigned with a list, right? So one reference is specifically from A and one from this particular function. Okay. So that is the reason I'm actually getting the answer as 2. Similarly, let's say if I go ahead and create another variable and assign B over here. Okay. And now if I go ahead and print the same thing with respect to B, so here you can see now that we will be getting the value as 3 because A is one reference, B is another reference, since B is referring A over here. And the other reference that is basically happening is by this particular function. Okay. Now let's say if I go ahead and delete this particular variable B. Now if I go ahead and print my sys dot reference of count of B. Okay. So here you'll be able to see that I'm getting an error because B variable is not there. So I'll just go ahead and see with respect to A. So here, okay, I cannot again execute B. So now let me just do one thing. Let me just go ahead and write B. Okay. So here you can see again, I'm getting the 2 value because B has got deleted now. Okay. And like this, when this value becomes 0, automatically the value variable or the memory will be deallocated. So that is what it says over here. Each object in Python maintains a count of referencing pointing to it. When the references count drops to 0, the memory occupied by the object is deallocated. So by using this reference counting, we specifically do this. Okay. And again, we should be knowing all these things because whenever we write some efficient coding or whenever we develop some kind of application, we can also use this, even though the Python actually handles all this kind of memory management automatically. Now let's go ahead and discuss about one more way or one more mechanism, which is specifically called as garbage collection. Okay. So we really need to know about garbage collection. I hope you have seen about constructor Whenever we define a class with the help of constructor, we are able to instantiate an object, right? In other programming language, there will also be something called as destructor. With the help of destructor, you basically deallocate all the objects memory itself, and we clean that particular objects, right? So in Python, you have something called as garbage collector, garbage collection. And this is nothing but it includes a cyclic garbage collector to handle reference cycles. Reference cycles occur when objects reference each other, preventing the reference counts from reaching 0. Okay. So let's see some example over here. Okay. And for this, we basically use the GC module. So we will go ahead and import GC. So GC is nothing but garbage collector. Let's say I want to enable the garbage collection. Okay. So if I go ahead and write garbage collection over here, so here you will be able to see that. I will just go ahead and write gc.enable. Okay. And I will enable this particular method. Okay. If I go ahead and execute it, so here you can see GC has got enabled. If you want to probably disable the garbage collection, so you can go ahead and write gc.disable and you can basically do this. Okay. Let's say I want to go ahead and manually trigger the garbage collection. So for this, you can go ahead and write gc.collect and we can probably define this. So here you can see this many reference, this many values are probably present. So if you go ahead and see this particular function, it says, hey, run the garbage collector with no argument, no runs of function, full collection. The optional argument may be an integer specifying by which generation to collect. Okay. The number of unreachable objects is written right now. This many number of objects are unreachable. Okay. It is showing in my entire, in my system itself with respect to my VS Code, wherever I'm working with different codes. So parallelly, I'm also running other VS Code that I have in my local. So based on that, it is showing, hey, this many number of variables are unreachable. Okay. Then if you also want to get garbage collection statistics, okay, collection stats. So for this, you can go ahead and write print gc dot get underscore stats. So when you see this get underscore stats and when you print it, so there you can see their collections 182 collected, 1611, and all these particular values are actually there. Okay. Again, in order to see what exactly this particular function does, again, it is a good way that in VS Code, you just go inside this particular bracket and you see this returns a list of dictionary content per generation statistics. Okay. So this is what is basically there. Okay. I will just remove this. So here are some of the information that has been collected. So collections is equal to 122, collected is 1611, uncollectible items is so much. So all these are basically giving me my garbage collection stats. Okay. And then if you want to get the unreachable objects, get unreachable objects. So here you can basically go ahead and write print dot gc dot garbage. Okay. Garbage basically means waste. So here right now it is completely empty because we don't have any as such over here, right? So these are almost everything that we have discussed with respect to garbage collection. Don't worry, we will be seeing more good examples as we go ahead. Okay. Now some of the good efficient techniques that we should probably be making sure with respect to this memory management. Okay. And here is what I'm actually giving you all point by point. Okay. So first one is that we have to definitely use local variable. You'll understand it once I probably print this. Okay. There are some points that everybody needs to keep in mind when we are working with all these things. So here you have, so memory management best practices. I can go ahead and create this. Okay. So first of all, we use local variables. Local variable try to use as much as local variables because local variable have a shorter lifespan and freed sooner than global variables. Avoid circular reference. So circular reference can lead to memory leaks. Circular reference basically means A is equal to B, B is equal to A. So these are like circular reference. We can also use generators because generator produce items one at a time and only keep one item in memory at a time. Okay, so we'll be seeing some examples. Explicitly delete objects. Use the delete statement to delete variable and objects explicitly whenever it is not used. And finally, you can also go ahead and use this profile memory usage using the memory profiling tools like trace malloc and memory profiler to identify memory leaks and optimize memory usage. So I will show you each and everything and I'll be showing you with respect to examples. Okay. So let's say I will first of all show you with GC module. So let's go ahead and import GC. I will go ahead and create my class. Let's say one of the class that I'm actually going to create is something called my object. Okay. Let's go ahead and define my constructor. So here is my underscore init. Here I'm going to take a variable called as name. Okay. And this is my class that I'm creating, my object. Okay. Here I am going to initialize self.name is equal to name. Okay. And then along with this, I'm just going to go ahead and write print. Let's print something over here. F object self.name created. Okay. So something like this, I want to print this particular message. Let's say there is also one more function which I will be using delete, so that you will be able to delete any object. Okay. I'll be using a self keyword over here, and let me just go ahead and print my F object. So here I'll say, hey, object self.name deleted. So if I want to probably delete it, I will be able to use this. Okay. Self.name deleted. See, memory management is all about how efficiently you are able to manage the memory. When an object is not used, it is better that you try to delete it. Okay. Now let's go ahead and create a circular reference. I will give you an example over here. So here it shows create circular reference. Let me go ahead and create my object one. So this will be my object one. Here I'm just going to go ahead and write my object one, and this will be nothing but obj1. Okay. Similarly, I will go ahead and write object 2. Then here I'm going to initialize my object, and let me just go ahead and write my object 2. Okay. Now, when I'm creating this particular object 1 and object 2, let's say that I'm going to refer. I'll say, hey, obj1.reference. I'm going to initialize it to object 2. And similarly, I'll go ahead and write obj2.reference is equal to object 1. So this in short is a circular reference. Object 1 is referring to object 2, object 2 is referring to object 1, right? So both the objects you can see over here, and obviously this is a bad thing. And here is one point that avoid circular references. Okay, it can lead to memories, this kind of problem statement. Okay. So guys, here you can see that I have actually made a object 1 reference with object 2 and object 2 reference with object 1. So this is basically called as a circular reference. Okay. Now let's do one thing. Let's go ahead and delete object 1, and similarly let's go ahead and delete object 2. Okay. Now here you can see after this particular operation is basically executed, both the objects will be unreachable. But this will not be garbage collected because due to circular reference, we have the circular reference of object 1 with object 2, object 2 with object 1, right? So for this particular case, what we really need to do, we need to manually trigger the garbage collection. Okay, garbage collection. So here you will be able to see that I will just go ahead and write gc.collect. Okay. And I will just execute this. Now, once I probably execute this gc.collect, you should be seeing that this message will get printed. What object is basically getting deleted, initially, if I just go ahead and execute delete object 1 and object 2, nothing will get executed. Nothing, this kind of statement will be executed because there is a circular reference, and because of the circular reference, it is not being able to detect those kind of objects, and so it is not able to delete them. So if I just go ahead and remove this and execute it, so here it shows that, hey, object 1 or object 2 is created. That's it, and these objects are deleted. But our main this delete function should get executed when the object is completely deallocated from the memory. Okay. So for in this particular case, since there is a circular reference, I will manually go ahead and trigger the garbage collection by using gc.collect. Now, if I go ahead and execute this along with this message, you'll also be seeing that this message will also get printed for both object 1 and object 2. Along with that, I'll also see that, let's go ahead and execute this first of all. So here you can see, object 1, object 2 created, then object 1, object 2 deleted, object 1, object 2 deleted, object 1, object 2 deleted. So this many number of times it is trying to delete because there is a kind of a circular reference, and since I had executed it 3 times, right, those circular reference was getting continuously built up, right? I executed it for 3 times. So that is the reason here you can see object 1, object 2, object 1, object 2, object 1, object 2 is deleted 3 times, right? If I do not manually trigger this, then let's say over here one more time, this kind of circular reference was basically getting created, right? And here you can see all the details and information with respect to this particular GC, that is garbage collector. Now, I hope you are able to get an idea what, like if you have a circular reference, what kind of performance it really impacts on your entire application. right? And obviously you'll not be able to free them quickly unless and until you go ahead and manually trigger this garbage collection, right? So now I will just go ahead and print all the collected garbage. So over here, so in order to collect it, I can just go ahead and write gc.garbage. It shows that, hey, right now this object has no attribute underscore path. It's okay because all the garbage collection has been removed from here, right? So all this particular objects has been removed from here. So I hope you got an idea with respect to import GC. Okay. And here we are just not handling with GC, but here we are also handling circular reference. Okay. Which is important. So handling circular reference. Perfect. Now let's go ahead and see generators, how we can use generators for memory efficiency. You know, generators, what it does is that generators for memory efficiency, and probably this kind of advanced, we have also discussed this in the advanced Python, right? So generators allows you to produce one item at a time. Yes, I hope everybody knows that because we use yield keyword. Generator allows you to produce one item at a time using memory efficiently by only keeping one item in the memory and removing that particular thing. Okay. So one example I can go ahead and give is that let's go ahead and create my function, which is called as generate numbers. And here I'm going to give my n variable and value. And what I'll say, I'll do for i in range of n, right? I'm just going to go ahead and write this yield keyword. Now yield keyword, what it does is that from this particular function, it will remove it'll get one of the element and it will return back to the place where we are calling. Okay. So now let's go ahead and use this particular generator. So whenever we write any generators, so there we use this yield keyword, right? So for num in, I will go ahead and write generate numbers. And let's say I want to go ahead and use so many numbers. Let's go ahead and see. Okay. And then I will just go ahead and print num. Okay. Because as soon as I write yield of I, it is just going to take one number. It is going to give it over here. I'll put one condition. If number is greater than 10, let's go ahead and break it. Okay. Now I'm limiting it till 10. Otherwise this will keep on getting executed. So here you can see how quickly 0 has got generated. It is passing it over here and it is printing it over here. We are calling this particular function, and this entire thing we have also discussed in our Python advanced sessions where we are discussing about generators, decorators, and many more things, right? So one numbers is specifically getting displayed. So definitely go ahead and use generators wherever it is possible for memory efficiency. Okay. Now coming to the next example, here we are basically going to use profiling. We are going to use something called as profiling memory usage. Okay. And here we are going to use something called as trace malloc. So first of all, let's go ahead and import trace malloc. So if we find a problem in this, so here, okay, fine, we have this import trace malloc. Okay. Now here I'm just going to probably use some easy functions. Let's say over here, what I am actually going to do is that I'll create a function which is called as create list. Okay. So let's say this is my create list. I'm taking for I in range of so many number of elements, and I'll go ahead and create another function. Okay. Let's say this is my main function, and here we are saying, hey, tracemalloc.start. We are calling this create list. Along with this, we are taking the snapshot with respect to the memory, and this snapshot has one important function which is called as statistics, and here is one important parameter which is called as line number, and we are printing this top stats 10 stats results over here. Okay. And I'll go ahead and execute it. So now let me just go ahead and call my main function. So here you can see top 10, it shows, hey, size 72 bytes, count 172. This all information is specifically there over here, right? So top 10, printing top 10, and this is what is the top 10 results. Okay. If you go ahead and see your top underscore stats. Okay. So if you also want to probably print everything. Okay. I will just go ahead and print this, and here are all the information that you are able to get it. See? So how much size is basically getting considered. So this in short shows you the entire memory profiling by using this particular library which is called as tracemalloc. Okay. So guys, this was some of the ways of handling memory management with the help of Python programming language. But always remember all these key points that we have specifically used. Like explicitly deleting objects, you have to probably use this del keyword in order to delete any objects which is not being used. But there will be some circular reference. So what you can do is that you can probably use this garbage collection method, which is called a GC collect. Okay. And again, other than that, I've shown you how to enable, disable, see the statistics and all. But all this important points that you really need to remember with respect to memory management best practices. So I hope you like this particular video. This was it from my side. Please make sure that you try to use all these techniques whenever you are developing an application. This will be very much handy for all of you. So I'll see you all in the next video. Thank you. Take care. Bye-bye.